Okay, so happy return to, I guess, my videos. So this one is kind of contingency tables within probability. This one is actually an interest to me because my daughter, my younger one, is a dancer. So I'm curious to see and work on this particular example. So you have a large set of dancers. Okay, so they were asked about their preferences with regards to the instructors and then the location that they're gonna or would like to train in. And these were the results. All right, so you have a table. So notice on the top it says location preference. So if they would want to train within the city or out of the city, maybe out of the state. So this is maybe for US. Or they have no preference at all on the location. And then on the left-hand side, notice, if they have a preference in terms of an age preference for instructors. So do they like younger instructors or do they like older instructors? Or if they have no preference at all. All right, so I'm going to take this. Now, with contingency tables, it's always nice to add up all the columns and rows. So I'm going to start that before I start answering these questions. So let me do that in fast forward mode here for you. All right, so I kind of summed everything up for us. So notice if you take the columns, you can kind of see how many would want to be within the city, within out of the city, out of the state, have no preference on location. And then on the rows, how many would prefer a younger instructor, how many an older instructor, and then how many don't have any preference at all. And then of course, when you add up the columns down, so I have 479 in total, I guess, in this particular study. And then the same thing should happen on the bottom. So it's kind of a double check that you added correctly. So now we can answer these particular examples here. So let's take a look and see what they're asking us. So probability that a dancer prefers to have a younger instructor. So that's part A. Okay, so younger instructor. So what I'm going to do is, what I like to do is I always kind of go and see, what are they asking me about? So, here is my younger instructor. Let me make this really big here so that you can see it. So here is younger instructor. So that's how many prefer a younger instructor. So if you want to know what the probability of that is, all right, so if you're going to be choosing this at random, so 232 of these prefer a younger instructor, and then you have to do it out of the entire total, so 479. So that's what that would be, and then you can turn it into a percent if you like. I'll just leave it as a fraction. For me, it doesn't really matter. I just want to show you how to tackle these. So that's what it would be for the younger instructor. All right, so that's part A. Part B. What is the probability that a dancer has no preference of the age or has preference of the location? Ooh, okay. So let's see how that one worked. Let me delete this previous one in here and let's see what they are asking about in this one. So I'm going to write here. So part B. So probability, and they have no preference of age. Okay, so no preference, okay, of age. And now it says or. So now here is or. So or has preference of the location. Has preference of the location. So this one is a little bit tricky. So now, no preference of age. So again, what I like to do is, I kind of go through. So here is no preference of age. So here, that's this one. That's this entire thing right here. Those are all the ones that have no preference of age. So there's really 77 of them, right? So that's what we have there. And then, it says, or have a location preference. All right. Well, my location preference would be basically all of these. So it's this one, all right, and this one. Okay, so these all have, okay, a preference for the location. So now I have to pick, all right, and then see the entire total. So that's pretty neat. So what I'm going to do is, because it's or, I don't want to count things twice. So I'm going to say, okay, so what's the probability, all right, of no preference plus what is the probability, okay, of a location? But now I have to subtract, all right? So I have to subtract the intersection between the two. So in order to write this, okay, so I'm going to do this. And that's what this is. And then I'm going to subtract the probability, because we don't want to count twice. So no preference, and this is on age, okay, intersected with the location. So we have to be careful here. So now, okay, so let's do all the counting. So no preference on the age, so we have 77 out of 479. Okay, so that's that first one. Now, next, plus, okay, so preference of the location. So now preference of the location, so notice that's this, plus because those ones are the ones that had a preference for a location. So I'm going to add all of these up. So that's going to be 200 plus 215 plus 39. So those are all the ones that had a preference, okay, out of the total. All right, so that's that. Minus, now where are they intersecting? Now, because I've highlighted my column, if you don't have a highlighter, you know, what I used to do is I used to just circle these, right? And then do it in pencil so that, you know, you can maybe erase it if there's another part or something. So here, so what I am running into is that I have, so notice this one, and this one, okay, I counted 2 times. So I have to subtract these. So it's going to be subtracted. So 35 plus 31 plus 1, okay, out of the total, which is 479. So that's a hard question, okay, but that's how we would do it. So now let's take a look and see. Notice the denominator is the same, so that's not a big deal. So now all you have to do is you have to take, okay, so we have 77 plus 200 plus 215 plus 39. All right, and now it's minus, I'll put these guys in brackets. Okay, so when you're subtracting all of this, 35 plus 31 plus 1. So in total, so notice, that's 464. All right. So that's quite a bit, but it should kind of make sense to us because notice it's pretty much everybody within here. All right. So here, this is my answer. All right. And then you can change it into a percent if you like. Now here is something, another way of approaching exactly the same question, and that's using complements. So you can take exactly the same thing, you'll get the same answer, is when you notice that when you're doing your, you're crossing out your columns or your rows, okay, notice what remains behind. Okay, so here, I'm going to highlight this for you. Notice the only thing you didn't highlight was this and this. Everything else you highlighted. So if you wanted to find, you can do it by complements, which basically means 1 minus, so this is 479. How many of these, so this one and this one, are the ones you wouldn't count, but everything else you would count. And that's, notice 8 plus 7 is just 15. So this is 15. And now, so what you have, well, 1, okay, so if you want to find a common denominator so that you're doing this, you're going to have this. So this is a much faster and easier way to do it. Okay, because you're just using the complements, and now notice 479 minus 15 is indeed 464 over 479, which is exactly the same thing. That is using the complement to find your answers. So whenever you have a union like this and it crosses out so many of your columns, it might be faster for you to do that. It doesn't matter which way you use. You should actually understand both, but you can apply any of them. All right, so that's part B. Let me now clean this up a little bit. Okay, so I'm gonna make this nice and clean for us. So that we can do part C. Part C says, what is the probability that a dancer has no preference of age and of the location? Now the word "and," right? End of the location. So there is no preference. So let's highlight these again. So no preference of the age. So we know that this is right here. No preference of the age. Right there. And, okay, of the location. So this, okay, this. All right. So they have no preference of the age and no preference of the location. Now the word "and" means that it's the intersection, right? So it's the intersection between these two. So if you're going to do that, all right, so the intersection between the two, so no preference for the age and of the location, then you're going to be left with, so here's 1, 2, and 3. That's the "and." It's the difference between "and" and "or." So notice B and C are exactly the same, except here it said "or," here it says "and." So now because of the "and," all right, they have to have, and we've actually kind of done this. Okay, so notice right here. So here was our "and." Okay, so this is going to be the answer for part C. So I can kind of cheat there. So this is probability of no preference, okay, of age and intersection, okay, of the location. All right, so in that case, so what we have is we have 35 plus 31, 35 plus 31, I guess plus 1, that's what that was, divided by the total, which is 479. So if you add these up, so it's going to be 60, I guess, 7 all over 479. So that word "and," we got to be careful there. That's it. That's all that we would do in this one for part C. All right, so just be careful there. Okay, let's clean it up again. And let's finalize. Okay, part D. What is the probability that a dancer has a preference for the age of the instructor or has a preference for the location? Now notice "or" has a preference for the location. Okay, so these are, okay, so preference, has a preference for the age. Okay, so that means has a preference for the age. So that's these two have preference for the age. Okay, so that's that. And then "or" has a preference for the location. So that's this one, preference of the location, and this one. Okay. Now, because it says "or," we have to count all of them. And I hope that from part B, you can see that we can just use the complement. So notice this is the only one that we haven't highlighted. So it is much easier for us, okay, because of the word "or," because we have to count all of them. In that case, to simply say, all right, for part D, okay, our probability of this, now this is "or," okay, So between the two. Now this is not the same thing as B, okay? So be careful, because here, okay, here we have a preference for the location and a preference for the age. Okay, in B we had no preference of the age. So what we have is, so I'm going to use the complement. So 1 minus, and that was our only one. So it's 10. So 10 over 479. And that's going to be 469 all over 479, which you can find the percents if you wanted to. But that's how you would tackle this one. So this is a fantastic question, which really tests your ability and understanding of these contingency tables. Now, please be careful, with the or, the and, the or, and then you can use complements if necessary. But when you highlight things or circle things, things really pop out at you. So remember, when it says and, it's the intersection. When it says or, it's everybody. Okay? And that finishes this example. Thanks for watching. See you in a future video. I hope that you subscribe. Maybe hit a like if you found this useful. Bye, everybody.